Hello everyone, Assalamu alaikum. Welcome to mini project 8, which is the final project here. We will be doing integrated project, which is a driver assistance system using ultrasonic sensor, LED, and a resistor. So let's get started. First of all, go to the folder. If you don't have it, you will find it in the link below. Click on Mini Project 8. So in this project, you are going to implement a parking assistance system to help drivers park their cars using visual alerts. The system measures the distance between the driver vehicle and its surrounding and responds accordingly. For example, when the distance between the driver's vehicle and the wall is too close, the system will alert the driver using a visual warning, which is the LED. Okay, so the aim is to build a driver assistance system using visual alerts. What is the project outcomes? Use ultrasonic sensor to detect the distance to the nearest object. This is done in project 7. Activate visual alerts when a certain condition happens. Use a breadboard diagram to build a system control circuit, and then finally use an Arduino code to activate alert based on distance reading. This time I want you to duplicate mini project 7 and we'll continue working on that one. So just click on this one here, then click on duplicate. So this is the copy of your mini project 7. If you didn't finish mini project 7, go back and finish it, then come back here. Double click here and name it mini project 8. Of course, your name and your class will remain the same, and then enter. So this is my mistake is here. So now let's start with the circuit here. Let's go to the project and let's see what do we need to add. So we need to add one LED here and one 220 ohm resistor. No need to connect ultrasonic sensor here. The Arduino is already there from the previous project, and the breadboard, it's a simple circuit. We don't need to use the breadboard here. Let's write here LED. This is an LED, just drag it here. Also, let's add a resistor. Of course, the resistor, you need to connect it direct to this one. You don't connect it here, connect it to here directly. And this one, of course, will be connected to the ground. Make it black. And this one, you can connect it to any of the other digital pins. So here connected to pin number 13. Of course, you can choose any one of the unoccupied pins here. So now we connect the LED to pin number 13. So here, since we added an LED, we need to declare it here. So end, give it a name. So let's name it LED equal. So we put it in pin number 13. So let's put 13 here and then semicolon. Since we connect electronic component here in this and one of any those digital pins, we need to add a pin mode here, right? So the pin mode here, make sure the M here is capital and copy the same name so you will not forget the capital or the small letter. And then you need to make sure that the LED, of course, it's output because it gives us a light. So output, make sure it's in capital letter. And then close it. Don't forget the semicolon here. Of course, inside the loop, we need to do the action based on the project itself. Now let's see what is the project here. So the system should work as follows. If the distance is less than or equal to 100 centimeter and greater than or equal to 50 centimeter, then the LED blinks with the following rates. So now here, until this code, based on the last one, let's delete the delay here because we don't need this one. So let's go to the last code here and start the logic. So if the distance is less than or equal to 100, so it's if, so we need to start with if else statement here. So if, here is the condition, and then here is the result. And then again else, if, open, and then close. You need to do this how many times? So this is for the first one. 1, 2, 3 times. So we need to add this 3 times here. Copy, paste, paste. So the first one, the distance, which is this one. So if distance is less than or equal 100 and, so here we need to use the logical operator, and distance is greater or equal to 50, greater or equal to 50, what should happen? The LED turns on for 100 milliseconds. So how to do this? By writing the letter right. Here the W is capital. The LED high for 100 milliseconds. So here for 100 milliseconds, the time we express it here by using the delay function. So delay 100 milliseconds, and then semicolon. So here what's inside this is in milliseconds, so we write M100 direct here. And then turns off for 1000 milliseconds. So let's repeat this one here and change the numbers. So here should be low, and here for 1000 milliseconds. Now let's repeat the same here. So let's repeat whatever inside the one here, repeat it after the F, and we'll change the number. The second one here is if the distance is less than 50 and is greater than or equal to 20. So if distance is less than 50 and is greater or equal to 20, what should happen? Turns on for 100 milliseconds, so turns on high for 100 milliseconds, good, and turns off for 500 milliseconds, turns off, which is low, for here 500 milliseconds. And then again let's paste here and do the third case here. If the distance is less than 200, so less than 200 or 20, and is greater than 10 seconds and greater than 10, you change the number here to 10, the LED blinks with the following rate. Turns on for 100 and turns off for 200. Finally, if it's less than 10 only, nothing else, it should be on for 100, which is here, and then off for another 100. And that's it. So now let's start the simulation and see the result here. Let's use the serial communication. The serial communication is used from the last project, which is here. Okay, so now the distance is 296, which is not in the range here. So to make it in the range, just go click here. When you click on here, you can change the value here. So see here, you can change the distance. You can think of this point here as the object and the car. Okay, so if it's 250, it's out of the ring. If it's less than 100 and larger than 50, let's make it less than 100 here. So this is less than 100. What happened? High for only 100 millisecond and then off for 1000 milliseconds. So this is the case here. Now let's test the second one. If it's less than 50 and larger than 20. So see here, 100 millisecond and then 500 millisecond. Now if it is less than 20, so if it's less than 20 but larger than 10, which is here 15, what should happen? It should be high for 100 millisecond and then low for another 200 millisecond. This is what's happening here. Finally, if it is less than 10, let's see if it's less than 10. What happened? 100 millisecond on, 100 millisecond off. So this is the case here. So that's it. This is the project, and this is the final project for a mini project 8. Take a screenshot for each case and upload it on LMS. Good luck.